Advanced scripting, basic error handling. Look, sometimes you know an error is possible, right? You're going to get a file and it might not exist, or you're going to connect to a computer and it might not be turned on, or it might have its firewall up. And you don't just want your script to explode when that happens. You want to kind of anticipate it and maybe do something about it. Now, it's going to take us a couple of nuggets to really explore this topic, but this is the starting place for error handling in PowerShell. This nugget is going to be all about error handling. Now we're going to start with a look at how errors actually work in Windows PowerShell, because if you want to be able to detect that an error has happened and then deal with it in some way other than just spewing red text onto the screen, then we need to understand exactly how PowerShell is processing the errors. And once we do that, we're going to cover some basic error handling. But I want to emphasize that what we're doing in this nugget is not going to be the end game here. The next nugget is going to dive a lot deeper into the topic of error handling because unfortunately there's about 97 different ways you do it, depending on exactly what you want and what you're working with. But we can't really do any of that until we get some basic structure and framing out of the way, and that's what this nugget is going to cover. Hopefully you recognize this module. It's the same module that I was playing with in the several previous nuggets. We've kind of been building on this thing. And now I'm going to do something to my getDiskSpaceInfo function. We're going to add some error handling to it. Now, I've got a couple of ways I can do this. The first thing I want to do is decide what it is I want to do when an error occurs. And the type of error I'm willing to anticipate here is the computer not being available. So I've got a couple of things I can do. In this case, what I've done is I've used that private check function to try and touch the computer first, and if it didn't, then I won't even try and do everything else. That's a great example of how to build a private function, but it's going to complicate the error handling example I want to walk through. So I'm going to take this out right now. So now, as it stands, this function is no longer doing any checking before it attempts to use getWMyObject to connect to a computer. Now that means the connection might fail. I might not have access to it. It might be turned off. I might not have permissions. A lot of things could go wrong. What I want to do is simply log the name of the failed computer so that I can then have a list of computers that failed, and if I want, I could use that as a way of retrying later. So I want to put it in a log file, but I don't want to have to pick a log file name up front, and I don't want to always have to specify one every single time I run this. So I'm going to create another preference variable. Example, error log file. This will default it to cerrors.txt. And then I need to make sure that that's getting exported. Example, error log file. Now remember, when you do this, you don't put the $sign, you just put the variable name. And now in my actual function, I can create a new parameter. So after this drive type parameter, put a comma. And now we're going to put a string parameter called error log file, and we're going to default that to that top level preference variable. So now when I run this, I can have my errors logged to a file cerrors.txt. If I want to change that, then when I load the module, I can change this preference variable in the shell. And if I want to override that on a particular use of this function, I can provide the -errorlog file parameter and provide whatever path and file name I want. Now, I guess we should probably start as if we mean to make this a good thing. So what if that file already exists? Now, since I'm going to be running through several computers, I'm going to need to append each failed computer to a file. Now, if I run this thing several times in a row and I'm just continually appending names, then it's going to get awfully big. So I'd like to start by removing the log file if it exists. Now, here's where we need to talk about what happens when PowerShell runs into an error. So I'm going to switch over to here. Let's say, for example, I have a file. We'll just make a quick little file, outfile test.txt. Okay? And I try to delete it. Remove item. Oops, ooh, we don't want to tab complete through all that. Probably don't even want to tab complete all that. There we go. I'm trying to be good. I'm so used to using the del alias. I probably should have just done that. Anyway, path test.txt. There we go. Okay, it worked great. No problem. If I try to run that and it does not already exist, I get an error. Now there's a difference in PowerShell between an error and an exception. Most PowerShell commands, if they run into a problem, but they can continue processing, will display an error message, and then they'll look at a built-in preference variable called error action preference, and that tells them what to do. So the default situation here is if you, as a command, run into a problem, but you think you can keep going, then display an error message and continue. Here's what I mean by that. Let's create another file called test2.txt. Now let's go back to our remove command. So I'm going to ask it to remove a file that doesn't exist and remove a file that does exist. It hits the first one, displays the error message, says, okay, I ran into an error, what should I do? Continue. Great, I'll continue with the second item. And if we look at a directory here, test2.txt does not exist. Let's see what some of the other versions of that are. I'll need to recreate that file. And now let's change error action preference to another one of its values. Silently continue. This is the one that you wish your kids had. Dad, I stubbed my toe. Silently continue. All right, let's try and do that remove again. So it removed test2.txt, but it didn't complain about test.txt being missing. That's because it ran into the error, and we said, shh, silently continue. All right, let's go with another option. The third option is inquire. And those are not case sensitive, by the way. You can type them in all lower, all upper, mixed case, doesn't matter. All right, let's create our file again. There we go, test2. Now let's run our remove command again. I ran into an error. I can't find test.txt because it does not exist. What should I do? Continue. And if you let it continue by hitting yes, then it does the same behavior, displays the error message and continues. As you'll see, test2.txt did get deleted, so it did continue. I could have halted the command, and then test2.txt would not have been deleted. Last option. Let's create our file again. Let's set error action preference equal to its last option of stop. And now let's run our remove command. Here's the difference. That's going to look a lot like continue did. But test2.txt exists. Hey, I ran into a problem. What should I do? I think I can continue. Nope. Stop. That turned the error into a terminating exception. It still displays the error message because I didn't trap that terminating exception and do anything about it, but it stopped the command. It did not proceed with the second one. So we need to decide what's appropriate. Now, you will find some folks who in their script will do something like this. Error action preference equals silently continue. And you got to spell it right. That's important. And then they'll say remove item path, whatever the error log file is. Right? The theory here is I want you to delete the file, and if it doesn't exist, well, mission accomplished. I don't care. Shut up about it. The problem with this is that you've just shut off all error messages for the entire script. I don't like that. If there's an error message, I'd like to see it because I think the error message might help me figure out, how to fix the error. Well, some folks will say, well, that's fine. We can just put it back to continue afterwards. I have a better idea. Why do we just not do that at all? Because every PowerShell command and function comes with an error action parameter that modifies the error action for just that command. That's it. Remove the item, and if there's a problem removing the item, shut up. I don't care. Now that's being a little cavalier because I might run into an error where the file exists, but I don't have permission to delete it. And I've just suppressed the error that would have told me that. But in this case, I'm willing to live with that possibility. I know where this script is going to run, and I think it's pretty remote. So now at the beginning of the script, I'm going to remove the whatever file we plan to log errors to. Okay. Now I need to decide where my error might occur, and it's right here on getWMyObject. So I'm going to wrap this in a try block. Try blocks are always paired with either a catch or a finally or both. You have to have one or the other, but you can have both, and I'll explain what they are in just a second. When a terminating exception occurs in a try block, PowerShell will immediately execute the catch block. After that, it will run the finally block. It will also run the finally block if there is no error. So we run this, and then we run this. If there's an error, we run this, and then catch, and then finally. Now, I don't plan to use finally, so I'm going to get rid of it. The trick here is what I just said, though. The catch block will only run if a terminating exception occurs in the try block, and by default, getWMyObject is not going to spew off a terminating exception because the default error action in the shell is continue. So I need to change that. You can also abbreviate this as EA. That's an alias for the parameter name, and you'll see that the tab completion recognizes EA, and it's giving me my options, and I want to stop. If this blows up, stop. Now the way I've constructed my script is I'm using a for each to go through all the computer names that were provided to the function. So by the time I get down to getWMyObject, I'm only working with a single computer anyway. So if I tell the command stop, do not continue, I'm not losing anything. I haven't lost any functionality because it's only one computer out of a list of one computer that failed. After it runs the catch block, it's going to loop to the top of the for each, then it'll get the next computer and try that. So by doing them one at a time, I kind of enable myself to do better error handling. Down here in my catch block, I'm going to take whatever the current computer name is, pump it to out file, whatever my error log file is, and I'm going to ask it to append. Now, if the file doesn't exist, out file will create it. If it does exist, the computer name will just get tacked on to the end. All right, let's save all that and come down here to the shell, import the module. Actually, I want to make sure I've been playing with this a lot, so let's just, okay, it was not loaded, but it's always good to check. Now let's try running it. Get disk space info, computer name. Let's give it one that works, one that doesn't, another one that should work, and another one that doesn't. And we'll see what happens. There's localhost. Now we're going probably, I'm guessing, through a WMI timeout, trying to talk to the computer named Nope. That should take it about 30 to 45 seconds to time out. I know it seems like forever when you're sitting here watching it. You really don't want to shorten that, though, because of the way WMI really wants to work. And then hopefully it'll get over to my domain controller. Hopefully I've got that thing turned on. Oh, there's the domain controller, and now we're waiting for the timeout on Mama. And there it is. But the real test here is, can we get the content from errors.txt, and there's the two failed computer names. So our error handling pretty much worked exactly as designed. Now there's a couple of tricks, and some of these are things that we'll need to get into in the next nugget. But this whole -EA thing only works if you're running a command. That might seem obvious, but let me show you what I mean by that. Let's collapse this function and go down to this other one I have here, set computer state. This one was also using this if check computer stuff. But let's assume that this is dealing with whether or not we can connect to the computer. I might still run into a permissions issue when I try to issue a shutdown command to a remote computer. So that's something I want to trap for. Try. Create our try block. Create our catch block. Indent this a line. Now, whatever I want to do in here is fine. The thing is, I can't actually catch the error unless it is a terminating exception. Now, I don't actually know if this Win32 shutdown method is going to return an exception or not. Sometimes they do, sometimes they don't. Sometimes it's going to produce a result object. And I'll have to check a property of that to see if it was successful or not. Depends on the method you're using. But because it is a method, you can't just stack an error action on. See, PowerShell's not tab completing error action because it knows it doesn't belong here. This isn't a PowerShell command. It doesn't have an error action parameter. So if it doesn't have an error action parameter, how can I make sure that PowerShell is going to make it return a terminating exception? Well, if it isn't already doing so, and it isn't giving you a return object that you can check to see if it worked, you could do this. And you can only do that legally, in my mind, if you follow it with this. In other words, I'm setting the error action preference to stop running the thing that might cause a problem, and I've set it to stop now, so this should produce a terminating exception if it's capable of doing so, but then I put the error action preference back where I found it. So you've got a couple of different ways that you can go about things here. Now, in the next nugget, we're going to talk a lot more about some of the depth that we get into with this, but I want to run this particular example through just a couple of more scenarios. So we have errors.txt. Let's run the entire command again, and I'm just going to give it localhost and nope, because I want to make sure that it's successfully deleting errors.txt. So instead of that containing nope and mama, it should only contain nope, because that's the only computer on this go-round that should fail. So there's my client, and we just need to wait for the timeout on nope. And there's that timeout, and so now let's see what's in errors.txt, and it's just nope. So it looks like my script is successfully deleting that. So you've really got two simple examples for basic error handling. The first one right here is when you really do just want to suppress the error. You don't care about the error message at all, and you don't really want to do anything about it. And that's using error action on silently continue mode. Now I've done that using the error action parameter rather than setting the global error action preference variable, because this is only scoping my silently continue to the remove item command that I'm running right there. It's not going to change other error actions elsewhere in my script. Later, with this particular command, I'd really like to do something about the error, so I set its error action to stop. That, when it runs into a problem, creates a terminating exception which I can then catch and do whatever I want to do with. Now, what if you also wanted to display some information about the error message? Well, there's another common parameter. In other words, this is a parameter possessed by all PowerShell commands called error variable. So error variable, my error. Do not put a $sign in front of this. It wants the name of the variable, not the contents of the variable, so you don't use a $sign. Now when an error occurs, it's going to get dropped into a variable called my error, and I could do something with it down here. Now when I want to get the contents of my error, I do use the $sign, so I'm doing a little verbose message here in double quotes. Let's save that. Remove module example, so it can load the new revised version into memory, and we'll make sure we run this with the verbose switch. So there's client. Let's see what happens when it finally times out on that nope computer. There we go. So, oops, sorry about that. So here's my verbose message, failed to connect to nope, error is, and then whonk, the entire thing. Now, this is another area that we're going to explore in a lot more detail in the next nugget, because sometimes what goes into that variable is not always what you want. It kind of depends on what you're after, and there's a lot of other ways you can access the error that just happened depending on your needs. And so in the next nugget, we're going to break those down and talk about what each of them offers so that you have a better chance of figuring out which way you should proceed given whatever situation you run into. So there you have it, a decent overview of exactly how errors work in Windows PowerShell and a little bit about basic error handling. Now, there is so much more to error handling than this. In fact, what we've covered in this nugget really is almost the best case scenario. It's what you can do if things work more or less perfectly, and if you don't necessarily need detailed access to information about the error that occurred. In the next nugget, we're going to dive a lot deeper into this topic, but I wanted you to have this basic framework in your mind before we went there. I hope this has been informative for you, and I'd like to thank you for viewing.